Let us integrate sec squared x tan x dx. Now, when you examine this, you see from your table of integral of derivative, if you remember them, is that the derivative with respect to x of tan x gives you sec squared x, right? But not only that, the fact is the derivative with respect to x of sec x will give you sec x tan x. Now, here, let us use this one up here, this derivative up here. These are the derivative. Let me put them in a box so that we can know we're just not supposed to erase them. Let us consider the derivative with respect to x of tan x equals sec squared x. Now, remember the general form of this is the integral of f of x, f prime x dx. That's the general form of it, all right? So we know that if we find derivative, if we substitute, let's say u is equal to f of x, then du by dx is f prime x. And when you transpose, we get dx is equal to du over f prime x. So what would happen is the integral of u f prime x f dx, which is du over f prime x, and f prime x would cancel f prime x, so we end up with the integral of u du, right? So that's what happens there. Now, let's consider here that we have u is equal to tan x. So we're going to differentiate tan x. The u by dx is sec squared x. So that dx is equal to the u over sec squared x. See that? So what we have is the integral of sec squared x, then tan x is u. We had tan x first, but we don't want tan x anymore, we want u. So it's u times dx, but dx is du over sec squared x. So we're not putting dx here, we're putting du over sec squared x. Now you notice sec squared x cancels sec squared x. So what we have is the integral of u du, which is u to the 2 over 2 plus c. Remember, it's u to the 1. U means u to the 1. To integrate, we add 1 to the 1 to get 2 new power, and then divide by the new power. What was u again? U was tan x. So what we have as our answer is tan x r squared. This is the same as tan squared x over 2 plus c. Tan x r squared is also written tan squared x. Alright, so what we have for our answer is tan squared x over 2 plus c. Let's write that down. So tan squared x over 2 plus c. Now, suppose we want to use the second derivative what it says is the derivative with respect to x of sec squared x, of sec x is sec x tan x. Let's see how we would do that. Let's erase the working we had before. What we have down here as well. Now, what we can do is rewrite this as sec x tan x. Alright? Then, here, we let u equal one of the sec x. U equals sec x. I'm keeping my mind on this one. It doesn't make a difference which one, but anyway, du by dx is equal to, when you differentiate sec x, you get sec x tan x. So it's sec x tan x. So dx, when you transpose dx, is equal to du over sec x tan x. See that? So when you rewrite this, it is the integral of u sec x tan x times dx, but dx is du over sec x tan x. So it's du over sec x tan x. Now, you see that sec x tan x will cancel sec x tan x. So what you have is the integral of u du, which is u squared over 2 plus c. But what was u again? U was sec x. So what you have is sec squared x over 2 plus c. So it is sec squared x over 2 plus c. So here now, the secant let's see if we can use our memory of trigonometry to see how these two are related. Remember, sine tan x is sine x over cos x. Alright? This is half and this is half, so we can scrap the half and just deal with this part. Sine x over cos x. So tan squared x is sine squared x over cos squared x. Secant, remember, 1 over cos. So 1 over cos squared x. Remember, the cosecant was 1 over sine. Secant 1 over cos. Right? Now, here, what we have. Alright, I didn't really need to work this part out. Sine x over cos x. What I did was use a graph plotter to see if they will give the same graph. That means same gradient functions, with the only difference being the constant of integration. So I isolated these parts and compare them. Tan squared x and I didn't really have, I see that the graph plotter can actually, it does recognize sec squared x, so I didn't have to put 1 over cos sec squared x. Now, as for the graph, this is a graph. This tan x is in red and the sec squared x is in blue. Alright? So, they have the same gradient functions. We zoom in. The only difference now is the displacement, the vertical displacement, which is given by the constant of integration. So same gradient function. So the derivative, using the gradient function of tan squared x and sec squared x are the same. The only difference is the displacement or the constant of integration, as we saw from the graph.